Hello, 6th graders. Welcome to Big Ideas Math, 7th grade math, section 3.1, algebraic expressions lesson. Pause while you write section 3.1, algebraic expressions lesson in your math notebook. Pause while you write the lesson objective in your math notebook. The lesson objective for today is to simplify algebraic expressions by combining like terms. Pause and write your vocabulary. Copy the words, definitions, and examples exactly as they appear into your math notebook in the Words Worth Knowing section. Like terms, terms of an algebraic expression that have the same variables raised to the same exponents. 4 and 8 are like terms, 2x and 7x are like terms. The simplest form of an algebraic expression. An algebraic expression is in simplest form when it has no like terms and no parentheses. 6a plus 9a squared is in simplest form, and 3t plus 5 is in simplest form. We're going to start on page 82 in your Big Ideas math book. Example 1, we're going to identify the terms and like terms in each expression. So, letter A, we have 9x minus 2 plus 7 minus x. So first we rewrite as a sum of terms. So everything before a minus sign, we just put a plus sign before it. And so it comes out 9x plus negative 2 plus 7 plus negative x. And that helps us recognize that we need to take the negative sign before the number. It also helps us later when we are simplifying the algebraic expression. So our terms are 9x, negative 2, 7, and negative x. And then our like terms, the terms that go together, are 9x and negative x and negative 2 and 7. Looking at letter B, z squared plus 5z minus 3z squared plus z. We rewrite as a sum of terms, so we put that plus sign in front of all the negative numbers, and we then have terms of z squared, 5z, negative 3z squared, and z. And our like terms are z squared and negative 3z squared, and 5z and z. And then we're going to start simplifying our algebraic expressions. And we simplify 3/4 y plus 12 minus y, 1/2 y minus 6. So we rewrite it as a sum, just like we did upstairs. And so it comes out 3/4 y plus 12 plus negative 1/2 y plus negative 6. And then that makes it work so that we can use the commutative property of addition, because we can't move subtraction around, but we can move addition around. So we have 3/4 y plus negative 1/2 y, and those two are conveniently located right next to each other now, plus 12 plus negative 6. And then the book uses the distributive property to help us add the 3/4 plus negative 1/2. It puts the y on the outside of the parentheses. And then we have 12 plus negative 6. So after you do the distributive property and add up everything that's in there and then redistribute the y, we've got 1/4 y plus 6. Now let's take a look at the on your own problems, which we will do together. So as I do these, you need to copy them into your notebook, and I'm going to pause a couple of times to erase, but you need to be sure you have everything in your notebook. So number 1, we're identifying the terms and like terms in the expression. So number 1, the terms are y, 10, and negative 3/2 y. So like terms, so the things that match up are y and negative 3/2 y, because those two have the same variable. Number 2, 2r squared is a term, 7r r is a term, negative r squared is a term, and negative 9 is a term. Like terms, we look for all the r squared, so we've got 2r squared and negative r squared. Those two go together. And then we have nothing else that matches up because 7r doesn't have a friend and negative 9 doesn't have a friend. And then looking at number 3, we have 7 is a term, 4p is a term, negative 5 is a term, p is a term, and 2q is a term. Like terms, so the ones that have matches, 7 matches with negative 5, and 4p matches with p. But don't include 2q because it doesn't have a match. Now we're going to take a minute and simplify these expressions in 4, 5, and 6. So our first step is to rewrite the expression using addition. So 14 plus negative 3z plus 8 plus z. And then we use our commutative property to switch things around so that the like terms are next door neighbors. So 14 plus 8 plus a negative 3z plus z. And then we can start combining. 14 plus 8 equals 22, and negative 3z plus a z equals a negative 2z. So at that point you can take out that extra plus sign because you don't need it anymore because you're done moving things around. So number 5, 2.5x plus 4.3x minus 5. You don't need to rewrite this using addition or as a sum because our like terms are already together. So you can just look at it and start adding. So 2.5x plus 4.3x equals 6.8x minus 5. So that one was easy peasy. And then number 6, 3/8 b minus 3/4 b. Again, our like terms are already together, but you do need to think about getting your common denominator. So 3/8 b and then minus 3/4 with 8 as a denominator is 6/8. So we end up with 3/8 b minus 6/8 b equals a negative 3/8 b. Let's take a real quick look at example 3, simplifying an algebraic expression, and the only difference between these and the last ones are that these have the distributive property in them. So for example, simplifying negative 1/2 times 6n plus 4 plus 2n, we have to deal with the parentheses first. So we have negative 1/2 times 6n plus negative 1/2 times 4, and then we still have our plus 2n hanging on the end. So negative 1/2 times 6n is negative 3n plus the negative 2 plus 2n. So we multiplied, and then we use our commutative property of addition to move things around, and then we can use our distributive property to combine our like terms, and then we end up with negative n minus 2. Now we're going to take a look at simplifying these expressions using the distributive property. So 3 times q plus 1 equals 3q plus 3, And then we can't forget our negative 4 on the end, or our minus 4. So when we simplify that, we've got 3q, sorry, that q is a little messy, and then 3 minus 4 equals negative 1. So it's 3q minus 1. Number 8, negative 2 times g equals negative 2g. And then negative 2 plus 4 equals negative 8. And then we have our plus 7g on the end. So we have negative 2g plus 7g. So we need to move things around. So we can rewrite this as a sum, negative 2g plus negative 8 plus 7g. And then we can move things around and have negative 2g. And let's put the 7g in front of that to make things simple. And then we have our plus negative 8. And it's sometimes easier to have the positive number in front. So you have 7g minus 2g, which equals 5g. And then you have that, which we know is negative 8. And then number 9 is 7 minus 4 times 3/4 x is 3x. So it's a negative 4 times 3/4 x. And then negative 4 times negative 1/4 is going to be a positive 1. And so again, we need to move things around. So we're going to go 7 plus 1, and then we have a plus negative 3x. And then we have, we combine and we have 7 plus 1 equals 8, and that equals 8 minus 3x. Okay, now we're going to look at example 4, our real life application. And we are going to the movies. Each person is buying a ticket, a medium drink, a large popcorn. We're going to write an expression in simplest form that represents the amount of money the group spends at the movies. And we're going to interpret the expression. So it doesn't tell us how many people are going to the movies, so that's going to be the part we don't know. But it does tell us how much each ticket costs, and each medium drink costs, and each large popcorn costs. So all of that is right here in words, and it tells us that x is our variable, which is the thing we don't know, which is how many people are going. And so then we start to write our expression. $7.50 for each ticket, so $7.50 x plus 275x plus 4x. And then we can add all of that up. You can use the distributive property, put it in parentheses and put an x on the end if you like, and it all adds up to $14.25 x when you add the coefficients. The expression $14.25 x indicates that the total cost per person is $14.25. So let's look at the on your own. What if each person buys a ticket, a large drink, and a small popcorn? So the price of the ticket doesn't change. We've got $7.50 for the price of the ticket, plus the large drink is going to be $3.50, plus the cost of a small popcorn is going to be $3. And then we have the x on the end here. So when we add this up, $7.50 plus $3.50 is $11, plus $3 is $14. And then we want to add the x on the end, not add the x, multiply the x on the end. So $14 times x equals our expression. To be sure you've completed this flip lesson, you need to be prepared with your notes, vocabulary, and all your other work completed, and have a good attitude and any questions prepared for your teacher.